So these can be a little tricky. So what is the first one? The one that has the, I assume we're just doing all of these, or just, does the check
Yeah,
mark
doing all
get it
these.
right, or?
Oh, no, I just want to do all these again just so I can get a good grasp of it. Since I'm like, I don't remember these that well.
Well, these can be tough. Here, let's look at what our four functions are. Let me do this first on my page because they're kind of hidden. It's hard for me to see what they are. Yeah, working these backwards can be challenging. And that's what they're basically asking you to do. Well, we can see that that's a combination of three of these things, right?
Mm-hmm.
In other words, it's a combination of that one, and that one. So what have I said to you? What is h of j of x? What would that be equal to? That's kind of the way to do these, is a little bit of trial and error. In other words, try something and you'll see what you have.
So J would go into the function of H.
No, in other words, what this means is h of the j of x function is x minus 3. So now what's h of x minus 3?
Square root of x minus 3.
So we're getting close. So what do we need to do to the h function to make it equal this function we're looking at?
Multiply it by 2.
Ah. Now, involving one or more. So the question is, here's what we really need. We need 2 times h of j of x. Isn't that what we did? We figured out h of j of x, which was the square root of x minus 3, and we want to multiply it by 2. Now the question is, can we use f of x in this? Yeah, what have I said to you? What is f of h of x? What's that equal to?
So that would be 2x minus 3.
No, h of x is square root of x.
So square root of 2x.
2 times the square root of x. In other words, f of h of x means this. It means f of square root of x. Well, if I substitute square root of x for x, I get 2 times square root of x. All right? Are you
Okay. I'm slightly confused about that.
Yeah, I don't blame you. It can be confusing. That's why you have to kind of look at it like this. In other words, whenever you see a composite function, f of another function, the very first thing you should do is fill in the other function. Well, we know h of x is square root of x, right? So now, do you know how to take f of square root of x? Remember what f of x is. F of x is 2x. So what would f of square root of x be?
Square root of 2x.
No, that's not the way you do it. When you have something inside the parentheses that's not x, you plug whatever it is in for x, not for the whole thing.
2 square root of 3.
So it's
Okay,
2 square root of x. That's what f of square root of x would be.
All right.
Okay? So now it looks like we need a composite of 3 functions. In other words, we already figured out that h of j of x equals that. Well, so what we really need is to add the f in front of that. So
Okay.
f of h of j of x is what I'm saying it is. Now let's figure out whether that's correct. Let's do it step by step. Don't do these anything but one step at a time. I erased all that so I could scroll back up so you could see the original functions. Okay? So, start from the inside. We've got f. I think this is the answer. Okay? Let's see if it is. We got f of h of, and then for j of x, let's plug in x minus 3. Okay? So what's that equal to?
So it'd be 2 square root of
No,
x
don't do
minus
the whole thing yet. Do it one step at a time. What's the middle part equal to? H of x minus 3.
So it'd be square root of x minus 3.
Okay, so now what I have is f of square root of x minus 3. And now what is that?
2 square root of x minus 3.
Which is our answer. So that's it right there. It's a composite of 3 functions, which is pretty unusual. I don't run into that very often. Let's see. Let's look at the next one. Hold on a minute. Let me erase some of this. The best way to do these is try to figure them out from the inside out. My voice is giving way. It's not at the last moment either. You're not quite my last session before holidays, but you're my second to last. No,
Okay.
third to last. I got an hour more tonight and an hour tomorrow morning. So let's look at this middle one. Y equals the square root of x cubed minus 3. Well, if we look at our 4 functions, we got an x cubed. We're almost certainly going to need that. We got a square root. We're going to probably need that. The x minus 3. I'm not sure we need that. Let's see. What would it be if I said, so g of x, let's see, if I said what is, and again, I don't know a great way to do these other than by trial and error. Just kind of play around with it. If I said this, what does this give you?
That'd be square root of x cubed.
Yeah, which is not quite what we have, but it's closer. So now how do I get the x minus 3 in there? So j of x must be part of it also, but it's not going to be g of j of x. Notice that g of j of x would give you x minus 3 quantity squared, or cubed rather. And that's not what we're looking at all. In other words, x minus 3 quantities cubed is a lot different than x cubed minus 3.
True.
This ends up being x cubed minus 6x plus 9. So this isn't really helping us get any closer to the answer. What are these check marks and minus signs? Does that mean you got the check marks right and you lost 6 points on this one?
Yeah, for partial credit.
How'd you get the whole first one right? It looks like you only used a double composite.
I have no idea.
That's not quite right either. That's not the correct answer. Notice that f of h of g is 2 times square root of x is all that is. Doesn't incorporate, oh, it is a triple composite. Excuse me. Okay, now I get it. In other words, you've shortened the notation to eliminate the x from these. So this is f of h of j, which is exactly what we came up with. This is f of h of j. Now down here, where you got it wrong, let's see what you end up with by these 3 composite functions. Maybe we'll get a clue on that. So you're saying it's h of g of j. Well, let's start with what g of j is. We already figured out that g of j is the quantity x minus 3 cubed. So now it's h of x minus 3 quantity cubed, which is merely 2 times x minus 3 quantity cubed. And that's not what we're looking at. We're looking at square root somewhere in there. So we've got to get the, oh, excuse me, I did that wrong. Never helps when the tutor does it wrong, does it? So h of that quantity would be the square root of x minus 3 quantity cubed. And that's not correct either, although it's closer. So I can see why you came up with that answer. But it's not correct, and that's why we lost 6 points. Now, the question is, how are we going to get it right? Are you allowed to use constants? In other words, does every this means you switched them? So he's telling you that it should have been h of j of g? Well, let's see if that's right. So he's saying it should be, hold on, h of j of g. Well, start from the inside. What is j of g equal to? G is x cubed minus 3. Ah, there we go. Now we're getting somewhere. Now all we have to do is take the square root of that. So apply the h to it. So now if I put the h in front of that, I get
square root of x minus 3.
Yeah. Okay. I might have had to play around with it a little bit more. However, notice that the first thing you do is figure out which equations need to be involved. Well, clearly it looks like the j function needs to be involved, the h function needs to be involved, and probably the g function. So you just have to figure out how to put those 3 functions together to get your answer.
Okay.
It's not going to help that I'm seeing the answers. Are there only 3 on this page?
Yes.
Okay, so I can't get to the others. Notice that this bottom one is x minus 3 times 2, right? In other words, I can factor a 2 out. So
yes.
I know I need to use the j function because I'm looking at an x minus 3. I need to use the g function because I'm looking at a function cubed. And after I factor the 2 out, I'm looking at the f function. So this should be a piece of cake. What I really have, if I want to rewrite it, and it's worth rewriting because upon rewriting it, you see something that you don't see unless you do rewrite it. And there you see the J function, you see the G function, and you see the F function.
Okay.
So if we work backwards, it should be F on the left, G in the middle, and J at the end. Now, what's G of J? Let's figure if that's correct. G of J is x minus 3 cubed, right?
Yes.
And what's F of that?
2x minus 3 cubed.
And that's exactly what we're looking at. Notice, ooh, no, we're not. No, that's not what we're looking at. Notice that this 2 that I got here is not being cubed, whereas I can't factor that 2 out in the beginning because it's all being cubed. So it's not f of g of j. It's the same 3 functions, but I got them in the wrong order. In other words, I don't want to factor that out first. I want to factor it out. Well, that's going to be my last step. So what I really have is 2x, the f of j, and then what I'm doing to all of that is g. That has to be the answer. See how I worked the logic there a little bit? What's f of j? What's this part?
That'd be 2x minus 3.
2x minus 6.
Yeah, 2x minus 6.
In other words, I'm plugging in x minus 3 wherever I see x. So the 2 is multiplying both of it. So this part here is 2x minus 6. So now I'm taking g of 2x minus 6, and that clearly is 2x minus 6 quantity cubed.
3.
So you kind of have to identify the functions that you're kind of looking at, and then put them in the correct order so that you get an answer that you're looking at. And it's hard to really describe the methodology other than that. The tough one for me was the middle one, the one you lost 6 points on. And the reason that's tough is because we weren't looking at an x cubed minus 3 in any of these functions. But it turns out that if you put them in the right order, in other words, the g in the middle, then you are looking at that. In other words, g of j is x minus, well, this wasn't the right answer. I'm sorry. I'm looking at your answers thinking they were right, and we had to go back to see the right answer. Just a second. Yeah. It was h of j of g, because j of g produced x cubed minus 3. you had to figure out what produced x cubed minus 3. You know you can apply the square root to that and get our answer that we're looking at, but you first have to, the toughest part of this problem is figuring out how to produce that. Well, turns out that that's j of g. And it makes sense because if I take my j function and substitute the g function for x, I get x cubed minus 3. And then I need to take the square root of the whole thing, so I apply the h function to it also.
Okay.
All right. Is this the only thing you sent me?
Yes, I'll send you something else now.
Okay. Tell me when it's sent.
All right.
Must be a busy internet night.
Just sent it.
Oh, just sent it? Okay.
Yep.
That's why I say tell me when it's sent, so that I won't keep clicking, waiting. Okay. Takes about 10 seconds once it's been sent. But it has to say sent on your phone before that 10 seconds starts. All right. What are the instructions here? Figure out the average rate of change between the 2 points?
Yes.
What's the subscript on this x?
On that one, it's a 1.
Oh, it's a 2.
I mean,
it's a 2 minus 1. Okay. All right. That's the formula for rate of change. Okay? It's, is the problem here to figure out the first derivative, the slope of the tangent line at this point? Because all of this stuff written here, that's the definition of first derivative.
Okay.
Okay? Now, but these notes aren't correct. I need to know the instructions on this. What's it say at the top of the page?
It says find the average rate of change of the function over the given interval.
Okay. Here's what average rate of change is. F of B minus F of A all over B minus A. That's average rate of change. Now, they've said g of x sub 2 minus g of x sub 1, same thing. All over x sub 2 minus x sub 1, right? Doesn't matter whether you call the 2 points A and B or x sub 2 and x sub 1. Okay? The problem is what is f of x sub 2 and what is f of x sub 1? What is f of x sub 2, which in this case is what? What is that point that I can't see because it's covered up by my stupid program here? Okay, now it's not covered up. So it's the 2 points are 2 and 0. So here's how I want to write it. I want to figure out what f of 2 is, and then I'm going to subtract f of 0, and then in the denominator, I'm going to write 2 minus 0. That's going to be your answer. That's average rate of change. Notice what else that is. Rise over run.
Okay.
Okay. So what's f of 2?
F of 2 would be... Wait, F of 2?
Right?
I'm still confused right now.
Well, what's f of 2? Or g of 2, excuse me.
Wouldn't that be 0, wait, 2? Oh, never mind. Now I see what you're trying to do. Okay. 4 minus
Okay,
4 plus 4.
okay, minus, what's f of 0?
0 minus 0 plus 4, so it would be 4.
Okay, and now what is 2 minus 0?
0.
2. 2
I
minus
mean,
0 is 2.
no. Never mind. Yeah.
Okay, so what this equation gives me is 0 divided by 2. What's the slope of that line between those 2 points? Right there. What's that slope? What's that number?
0.
Yeah, and you've got it written down here at the very bottom. It's 4 minus 4 all over 2, which is 0. Well, you might say, well, how can it be 0? Well, think of what we're looking at. We're looking at a quadratic that opens up. Clearly, the slope of the line was between 2 points like that, and it was a flat slope. So this point was 0, and this point was 2. And the average rate of change between those 2 points was 0.
0.
Remember what average rate of change means. It means slope. In fact, the most important word in your math dictionary language for the next year is the word slope. I cannot impress people upon that enough. You've been dealing with slope for 3 years from Algebra 1. Well, there's a good reason for it. It's because by the time you get to calculus, slope is everything. Slope is the definition of first derivative. And in fact, this f of x plus h minus f of x all over h, that's the formal definition of slope. Only it's the limit of that as h goes to 0.
Okay.
That is the definition of slope, and that's why somebody wrote that in there. That doesn't have much to do with this problem. This problem says, what's the average slope? Notice there's a huge difference between average slope, which is Algebra 1, Algebra 2, pre-calc, and instantaneous slope at a point. That's calculus. In other words, if I want the slope at that point right there only, I need to figure out the slope of the tangent line. That's what calculus does.
Okay.
Okay? All right, let's see. We're going to do the same thing for this function. These instructions down here are exactly right. You're going to take g of the second point minus g of the first point and divide it by the second point minus the first point. This triangle allows you to evaluate all the functions. In other words, that allows you to know what g of x sub 2 is. In other words, what's the tangent of 0? Well, it's 0. What's the tangent of minus pi over 3? Well, that's a 60-degree angle, so the tangent of that is square root of 3 over 1, but it's negative because it's a negative pi over 3. So you have to be able to figure out what g of x sub 2 is, and you have to be able to figure out what g of x sub 1 is, and then divide the whole thing by 0 minus a minus pi over 3. And the only thing important here is that the orders be the same. You can actually switch the order if you want. You could make this x sub 1 and this x sub 2, but then the denominator would have to be x sub 1 minus x sub 2, not x sub 2 minus x sub 1.
Okay.
Okay. So this looks right, whatever this is, except that needs a minus sign on it. Because you're taking, remember, g of x sub 2 is 0, and then you're subtracting g of x sub 1. Here's one thing that I see missing from your work that you don't want to be missing. Okay, let me just take one more minute of your time here. You want this step right here. That's 0. And then you want this step right here. And you want to write these down. I don't see it written down anywhere. Well, that is square root of 3.
Okay.
Okay? So when I take the numerator, I've got 0 minus square root of 3. And then the denominator is going to be 0 minus a minus pi over 3. I got to go in the same order. So what I end up with is 3 or root 3 over a positive pi. That was the average rate of change. And you get that also if you flip the denominator and multiply, which you always want to do. In other words, you always want to simplify this. You don't ever want to have a quotient in your denominator because there's no reason to have it. It can always be simplified. You're always going to flip and multiply. So I end up with 3 root 3 over pi. Somehow you got your signs wrong here. I'm not sure how. Oh, I got mine wrong. It is minus. In other words, this is minus. The numerator was minus all along. The denominator turned positive, which gives you a minus answer.
Okay.
Okay. All right. I'll let you go. But that's the way you do all of these average rate of change problems.
Got it. Thank you for your time, Mr. Cowan.
You're welcome, Taylor. You have a good holidays. I'll probably talk to you after the holidays.
Okay, sounds good. Appreciate it. See you then.